Hey guys, so welcome to the Identifying Patterns lecture. In this lecture, we're going to learn about different types of number patterns as well as geometric patterns, which are basically just patterns made of geometric shapes. From these patterns, we're going to learn to construct rules or linear equations in order to describe such patterns. Now, this is a really important concept, guys, and will be used extensively to construct linear equations in higher grades, such as grade 9, 10, and beyond. So an example of a number pattern could be 2, 5, 8, 11, etc. So as you can see, it is simply going up by plus 3 each time. So that is the number pattern for this numbers here. And then we have geometric patterns example. So as you can see, this is my crude drawing of a few houses that are lining up next to each other. So the very first one is a single house, which is made up of 6 different sticks. So that's 1 stick, 2 sticks, 3, 4, 5, and 6. Then we have 2 houses now sharing that middle stick here. So the sticks don't simply double, but it becomes plus 5 because that single stick is now being shared by both houses. So that's one pattern. So this has now gone up by 5 sticks. Then 3 houses in a row, as you might imagine, that has also gone up by 5 sticks because then it leads up to 16 sticks. So guys, these are examples of different types of patterns that we might have to work with and use to construct linear equations. So why don't we get straight into the questions and see how it works. Okay, so let's have a look at this question that involves number patterns. It says, write the next 3 numbers for each of the patterns below. We have 3, 7, and then 11. So if you notice here, the numbers are simply increasing by plus 4. So the pattern there is that each number is simply increasing by 4 each time. So the next 3 numbers will be, so it's 3, 7, and 11. The next number will be 11 plus 4, which is 15. Next one will be 15 plus 4, which is 19. Next one will be 19 plus 4, which is 23. So these are the next 3 numbers in the pattern for part A. Let's have a look at part B. We have 23, 20, and then 17. So again, if you notice, the numbers are simply decreasing this time by 3. So we have 23, 20, 17, and it's going down by 3 each time. So 17 minus 3 is 14. 14 minus 3 is 11. 11 minus 3 is 8. So our next 3 numbers in the pattern are 14, 11, and 8. Then we have 2, we have 4, and then we have 8. Now this time, guys, you'll notice that the pattern is actually involving multiplication because this one goes up by times 2, and so does this one. So we have 2, 4, 8, then 8 times 2 is 16, 16 times 2 is 32, and then 32 times 2 is 64. So the next 3 numbers in this pattern is 16, 32, and 64. Alrighty, let's have a look at part D. We have 128, then we have 64, and then we have 32. So if we notice, then each of these numbers are simply getting halved each time. So from there becomes 32 divided by 2 is 16, 16 divided by 2 is 8, 8 divided by 2 is 4. So 16, 8, and 4 are the next 3 numbers in this pattern. Then we have part E, which is 1, 3, 9, 27. So here, guys, again, a multiplication factor here. So we have times 3 for this one, times 3 for this one, times 3 again for this one. So again, we have to go through the process of finding the next 3 numbers. So 27 times 3 is 81. 81 times 3 is 243. And 243 times 3 is 729. So 81, 243, and 729 are the next 3 numbers in this pattern. Let's have a look at the very final one. Now, if you want, you can pause the lecture at this stage and have a go at the pattern that you can see in part F. Alrighty, so we have 1, 4, 9, and 16. So if you notice, there's a increase of plus 3 for this one, increase of plus 5 for this one, increase of plus 7 for this one. So if you'll notice that each number is simply keep getting increased by what was before plus 2. So this one went up by 3. So the next one went up by 3 and a 2 on top of that. This one went up by 5 and 2 on top of that. So the next one will be a plus 9. The one after that will be a plus 11. Then the one after that will be plus 13. So 16 plus 9 gives us 25. 25 plus 11 gives us 36. 36 plus 13 gives us 49. So 25, 36, and 49 are the next three numbers in this number pattern. So guys, just getting your mind to start thinking about how patterns work will really help you in determining linear equations in the higher grades when you have been given a certain amount of information. So guys, now let's move into geometric patterns and see how we're going to work it out with those. Alright, so let's have a look at this question that involves geometric patterns. It says, consider the following geometric pattern and answer the following questions. Part A says, draw the next two figures in the series. So why don't we do that? So this is figure number 1, figure number 2, and figure number 3. So figure number 4 will obviously just have 4 different triangles in there. That's figure number 5 right there. Part B says, draw a table to show a relationship between the number of triangles and the number of sticks. So the very first triangle here has 3 sticks. So there's 1, there's 2, and there's 3. Sticks or sides, whatever you want to call them. So 3 there, 6 there, 9 there, 12 there, and 15 there. So let's just draw a table. So we have triangles will be T, and sticks can be S. So when there is one triangle, we have 3 sticks. When there's 2, we have 6. When there's 3, we have 9. When there's 4, we have 12, and etc. C says, write a rule to describe the relationship. So guys, as we can see, as one triangle goes up, so if there's one more triangle, there are 3 additional sticks. Similarly, another triangle comes in, another 3 sticks come in. So that right there is the relationship between the number of triangles and the number of sticks. So the rule here, guys, is the number of sticks, as we can see, is simply 3 times the number of triangles. So if there are 3 sticks, there is only 1 triangle. Or alternatively, if there are 2 triangles, there are 6 sticks. 3 triangles, 9 sticks. So the number of sticks is simply 3 times the number of triangles. So S, which is sticks, is equal to 3t, or 3 times t. So our relationship here is simply S equals 3t. Now part D says, how many matches will it take to make a figure of 13 triangles? Pretty straightforward. All we have to do is take that number 13 and simply substitute it into our rule that we found, which is simply S is equal to 3 times 13, which is equal to 39. So what's that telling us? It's telling us that there are 39 sticks for 13 triangles. Let's have a look at the next question. Alrighty, so let's have a look at this question. It says, consider the following geometric pattern and answer the following questions. Draw the next two figures in the series. So we have this house here. As we can see, there are 6 different sticks that make up this house. So there's that one, that one, that one, that one, that one, and that one, which is 6. Then we have this one, this one, this one, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So as we can see, the pattern is simply going up by 5 each time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the next two will be 4 houses, and then 5 houses. So since the pattern is 6, 11, 16, it's just simply going up by 5 sticks each time. So this will be 21. This will be 26 number of sticks to make 5 houses. Part B says, draw a table to show the relationship between the number of houses, so that should be houses, apologies, that's a typo, and the number of sticks. So let's draw that out. We have a number of houses here, and we have the number of sticks here. So one house is equivalent to 6 sticks. 2 houses gives us 11 sticks. 3 houses gives us 16, 4 gives us 21, and then 5 gives us 26. So that right there is the table that shows the relationship between the number of houses and the number of sticks it takes to make up those houses. Part C says, draw a rule to describe this relationship. So as we can see, guys, the number of sticks goes up by 5 each time there is an extra house. So that's the geometric pattern there. So it's going up by 5 sticks each time there is an extra house. However, if we multiply, just like we did in the previous one, if we multiply this number by 5, it does not end up giving us the number of sticks that we need. Because 1 times 5 is just 5, 2 times 5 is 10, 3 times 5 is 15, 4 times 5 is 20. We're always off by 1 stick each time. So the equation could be S, the number of sticks, is equal to 5 times the number of houses plus 1. That right there is our rule, because if we do 5 times the number of houses for this one, that becomes 1 times 5 is 5, plus another one gives us 6. 2 times 5 is 10, plus 1 gives us 11. 3 times 5 is 15, plus 1 is 16. So that right there, guys, is the rule that we need. So the number of sticks is equal to 5h plus 1, where 5h is simply 5 times the number of houses. Then part D has, how many matches will it take to make a figure of 10 houses? So again, it's a simple matter of substituting 10 into where the h is. So we have S equals 5 times 10 plus 1. 5 times 10 is 50, plus 1 is 51. So it will take 51 different sticks to make up 10 different houses that are structured like this. Let's have a look at the next question. Alrighty, let's have a look at this question. It says, consider the following geometric pattern and answer the following questions. Draw the next 2 figures in the series, draw a table, write a rule, and then finally answer another question in part D. Same as before. So we have squares this time. So 1 square gives us 4 different sticks. So 1, 2, 3, 4. Then 2 squares gives us 1, 2, 3, 4, 5, 6, 7. 3 gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as we can see, it's simply increasing by 3 sticks each time. So let's draw out our 4th shape, which simply has 4 squares. Then the 5th one will have 5 squares. Pretty straightforward here. So this one will have 13 sticks. This one will have 16 sticks. Draw a table to show the relationship between the number of squares and the number of sticks. So let's call it SQ for squares and S for sticks. So 1 square is 4 sticks, 2 squares is 7, 3 squares is 10, 4 is 13, etc. That's our table right there. Part C says, write a rule to describe the relationship. So again, guys, we need to compare the values of the number of squares to the number of sticks. So as we can see, the pattern here is that it's simply going up by 3 each time. Pretty straightforward. So the number of sticks is equal to 3 times the number of squares, as we can see. So 1 square, 3 times that is 3. So 3 times the number of squares. Then we add simply a 1 after it. So 3 times the number of squares is 3 times 1, which is 3, plus 1 gives us 4. 3 times 2 squares is 6, plus 1 gives us 7. 3 times 3 plus 1 gives us 10. So our rule for this relationship is simply sticks is equal to 3 SQ plus 1. And then we can use that rule to simply answer question D. It says, how many matches will it take to make a figure of 20 squares? So we have S is equal to 3 times 20 squares plus 1. 3 times 20 is 60, plus 1 is 61. So it will take us 61 matches or sticks, whatever you want to call it, to make a figure of 20 squares. So guys, that brings us to the end of the Identifying Patterns lecture. We learned to work with different types of patterns, may they be number or geometric, to come up with certain relationships, and also discern the rules that describe those relationships. As I said, this is a very important skill set to have for higher grades, where we are going to be doing this to construct linear equations with information that's been given to us in table form. So guys, I hope that this lecture was useful to you. If you feel like you're fairly comfortable with the content of this lecture, please do have a go at the worksheet. If something doesn't make sense, please get in touch with me on the discussion board, and I'll be happy to answer any questions or issues that you might be facing. From here, I will see you in the next lecture, where we work with unknown variables on both sides of the equal sign. Thanks, guys.